Well, that's why we're here. Science. Science is a systematic way of observing, testing, and analyzing the natural world. Key important points here. It is systematic, and it is testing and analyzing, so you end up with data. Science is a way of finding and supporting facts, and you don't have facts unless you have evidence or data. Otherwise, it is just opinion. It's critical that when science is carried out, that the scientific method is used. Scientific method could look slightly different from one, experiment to the next, one approach to the next. I'm going to assume that you guys pretty much know, the steps of the scientific method, and we'll go over that a little bit more as we design experiments later in class. However, there's one part that we need to talk about that we haven't talked about too much, you may not have in the past, and that is the last part of the scientific method is the repeating of experiments and peer review. Okay? If this is not carried out correctly, you get real problems. Here's some examples. The South Koreans back in the 1990s successfully cloned a dog, although later it was determined that they didn't actually clone the dog, that the scientist who did it fabricated his experiment, and it wasn't a success. Now, why is this important? Because oftentimes when you get a study that is done and it comes out really groundbreaking, that can determine where funding is going to go in the future, right? So if you get a successful experiment, you're likely to get more grants and more funding put towards that type of research. And that was probably the goal of, him lying about successfully cloning the dog. And another one that really affected the United States, there was a doctor who published work that stated that vaccines cause autism. Okay, it really blew up in the papers. Everybody talked about it. Word spread on social media, and as a result, a lot of people stopped getting vaccines because they thought that it was going to cause autism in their children. I mean, obviously, it's a concern if it's a true study, and it was found out later, about a year or two later, it was found out that this scientist actually fabricated his work and doctored his data, and when he was punished for this, he was stripped of his license and all that. It ended up like back page news. It was not front page like the study that said that, oh, you shouldn't get vaccines. So a lot of people didn't pay attention to it, or maybe even just didn't get the message that he had lied about his research. And as a result, we still today have people who will not get vaccines because they think it causes autism, even though that was not ever peer-reviewed and not ever been able to be replicated, okay? So if it's good science, the experiment has to be replicated by other scientists. It has to go through peer review so they can look at it and, edit it and analyze it and see where the problems were. When this is done, this leads to what's called sound science. Sound science is based on sound facts. That's where the name comes from. It involves lots and lots of data. It is not just a small sample. Sound science does not refer to just one study that was done, which is the first time anybody's ever seen anything about this study. It is something that is constantly tested, and science is worldwide. So it is pulling together a collective of knowledge from all worldwide international scientists looking at issues. Okay, this is what leads to sound science. So here's how the process works. You get observations from things that you've seen or read or heard. That leads to questions, which then get you to do some more research and get further observations. Maybe you find answers. Maybe you just end up in here. Somebody's already done work on that. But if you have further questions, the next step is to develop a hypothesis. Once you develop your hypothesis, you then design an experiment, okay? And you carry that out, and if that experiment ends up contradicting your hypothesis, then you take it back and review it. Say, well, what could have been the results of this? Why did it come out this way? What else could be the answer rather than my hypothesis? If you do an experiment and it supports your hypothesis, you hopefully get those answers, and then you publish that so that other people can see it. It goes through peer review. People look at it and say, yes, that's valid. And then they maybe design their own experiments with it. And that's how we get a building of knowledge that furthers scientific research in the future. Eventually, you could end up having many hypotheses that formulate theories, which are very well founded and generally accepted as true, okay? And if it's just an explanation of how the natural universe works, then it ends up being, a principle or natural law. If the sound science principles are not followed, you end up with what's called junk science, okay? Here's where information is presented as valid science, but it does not conform to the rigors of peer review. It does not follow the scientific process. Here we have selective results, possibly, that are put out. Maybe it's alternative facts, to use a more relevant term these days. Maybe a scientist found, in 4 groups of his experiment, he got one group that really proved his point. The other 3 really didn't show it so much, so he really just focuses on that one point and puts that out there. That would be junk science, okay? Or if it's the only study of its kind and uses a very small sample size to show its results, that could be junk science. Here's a few quick examples of some junk science studies and things that are out there. Obviously, the tobacco industry hid their results for years, the studies that were being done, and they had a huge ad campaign and lobbyist efforts to try to hide the fact that nicotine and tobacco smoke causes cancer, okay, because it hurt their bottom line. Carbon dioxide is harmless because we create it. There's a company or a nonprofit organization called the Heartland Institute. It's mostly funded by the fossil fuel industry, like the Koch brothers. You can look up the Heartland Institute, and their whole goal is to spread the seeds of doubt in the American public, not to disprove climate change, but just to get people to think that maybe it's not true. The first attempt that they gave at that was to put out the idea that carbon dioxide can't be a pollution and it can't hurt us because we breathe it out. There are golf courses. There was a huge push to try to get golf courses put into state parks, and it was the kind of industry of golf that tried to get those done because that would be, places that where people could go and play golf, but they tried to push the idea that it's good for wildlife. And any forest biologist is going to tell you that a golf course is absolutely the worst thing for wildlife. You take a natural ecosystem and fill it full of chemicals and mow it really, really short and put a lot of people on it. Then there was this whole societal group that was pushing the idea that fluoride is unsafe, causes tooth decay. Actually, that's the opposite completely. Oftentimes, fluoride is pumped into public drinking water because it actually builds tooth enamel and prevents tooth decay. But it got into the papers. There were some people that believed that it was unsafe and it caused your teeth to decay. And there are still, as of today, states and cities in this country that will not put fluoride in the drinking water because they believe it's unsafe. Okay, all of these are examples of junk science that have some sort of motivation behind them, and we really want to try to avoid that. We have this war on science that goes on in the United States for some reason. The anti-fluoridation campaigns is an example. There are people today that believe the Apollo moon landings were fake and that all pictures taken from outer space of the Earth are part of a giant conspiracy, and that none of that is true. We have these giant climate science conspiracies. Some of it is funded by interest groups that would be kind of put out of business, like the fossil fuel industries, if people tried to change the way they did things. In the United States, we still have 25 to 30% of our public that believes that climate change is a myth, that it is not real, and that it's a hoax. And even when Donald Trump took presidency, he publicly stated to the press that he believes that climate change is a hoax that was created by the Chinese to try to boost their business interests and their economy. Okay, so even though there's tons and tons and tons of data, and if you look around you, you can see the climate changing, there are people who believe that that's not the case, even to the point where there's people who believe today that the world is flat, and it is a disk that has a giant ice wall surrounding it so the water doesn't fall out, and if you fly off of one end of it in a plane, you automatically get transported to the other end of it and start going across. So that's how people can still fly around the world. It's often called the Pac-Man theory, because if you ever played Pac-Man, you go off one side of the screen, you come back on the other side of the screen. So people will believe that rather than actually believing science. And there's several reasons for that. One of the reasons is that science appeals to our rational brain, but often we're motivated more by our emotion and our interest in remaining close to our peers. So people believe that the tribe is more important than the truth, right? If I believe what my neighbors and the people around me in my circle of friends think, that's going to be more important to me to fit in than believing the actual truth, okay? And there's a lot of people who psychologically just don't want to be told what to think, and their first response is going to be to question what they hear, whether they believe it to be true or not, and it is a psychological thing, okay? And they feel like a belief in science is sort of giving in to the man, right? And science gets lumped together with the man, like the government, okay? Here in environmental science, we're looking at, well, what is environmental science? First of all, study of ecosystems and ecology, but it's not just that. We have to add humans into that, okay? How does the earth affect humans, and how are humans affecting the earth with our use of natural resources? So it's not that we're trying to stop using resources, but how do we affect those? Okay, that's what environmental science is. Now, why do we have so many more disagreements than physics or chemistry, for instance? Reason is because environmental science is super interdisciplinary. Not only does it combine biology and ecology with chemistry, physics, and geology, so you've got all these sciences overlapping, but then you add in things like economics and political science, and we're going to study laws, right? And so these all overlap with science, and when you have a conflict of interests, then you get a lot more uproar. Environmental policy, typically, the politics of it, where the laws come from, is driven by public opinion. It should be. What people want is what the law should be. However, it is often just as much driven by lobbyist groups, which are economically motivated as much as politically motivated, right? So business decisions often drive policy as much as public opinion does, and that's very much true in environmental science. We'll see that throughout the course. There's two schools of thought, and I want you to always think about where you fall on this continuum. There are takers, those who believe that the earth here exists for humans' exploitation and benefit, and that the resources are there for us to use. This is the idea that resulted in the complete cut down of all of the forests in the northern half of Pennsylvania in the late 1800s and early 1900s. There was hardly a tree left that was taller than 10 feet. And then there's the leavers, those that believe we are a very small piece of the Earth's giant ecosystem, and that everything has the same right to those resources as we do, and that we need to live in a way that's going to give them that same right. Very few people can fall on either end. Neither one is really an acceptable way to run a society. So we want to think about sustainability. We're looking for, how can we live how we want to live? How can we still have our technological comforts that keep us alive and keep us healthy and support a viable, self-sustaining environment at the same time? Okay, here's a few examples that you can look at that we'll discuss throughout the year, but we want sustainability. We want to be able to use our resources, but only at the rate at which it's not going to deplete those resources. Okay, so in order to come up with sustainable solutions, they have to be three things. First, socially desirable. People have to want them. If you come up with a new recycled product, but nobody's willing to buy it because they don't want it, it's not a sustainable solution. If that product that you come up with costs too much for people to buy, it's not economically feasible, that's not a sustainable solution. So people have to want it, and it has to be, low enough operating costs that it'll work. And lastly, it has to be ecologically viable. It can't hurt the environment so much to do it that makes it unsustainable, right? So in order to get sustainable solutions, we have to have the overlap of these three things. And when we find that, that's things we can move forward with. So that's the end of part one. You can hold on to your notes until you do part two.